Hello calculus students, my name is Tyler. This video is for anyone beginning calculus. The video focuses on the product rule for taking derivatives, so if that's what you need help on, you come to the right place. In a nutshell, a derivative represents the rate that something is changing. Think back to algebra or other classes that you're already familiar with, like the slope of the line in the graph. The slope is the rate at which that graph is changing. The derivative of a function is very, very much related to that. Depending on the function you're given in, say, a homework assignment, you can take the derivative of that function with one of four common rules. Those four rules are the power rule, the product rule, which we're going to talk about today, the quotient rule, and the chain rule. And this video, again, focuses on the product rule. So before starting the product rule, we need to go over the power rule because it's just essential. Hopefully, by this time, you should already know what the power rule is. But if you don't, or if you've forgotten, you just need a refresher. We'll go back over it because it's essential. So if you're given some function, f of x is equal to x cubed. That's your function. Now you want to take the derivative of f of x. The derivative of that, we use the power rule. The reason using the power rule is because it's going to involve the power of x up here. What you do, f prime of x, prime meaning the derivative, it's just shorthand. A lot of time you may see another way to represent the derivative, like d over dx of f of x. That's another way to represent the derivative. Put an equal sign here because letting you know they're the same thing, okay? The derivative, f prime of x, is equal to, we bring down the 3, so the 3 comes out in front of the x, put the x there, and then we subtract 1 from the power. So 3 minus 1, what? 2. So 3x squared. So if our function is f of x equals x cubed, the derivative is 3x squared. Okay? A more general way to write this is f prime of x of any given function is going to be equal to your original power, n, in this case, 3 is n, times x to the n minus 1. Exactly what we did here. N, which was this 3, we put it in front of the x, and then we took n, which was the 3 again, and subtracted 1. So that's the general formula for the power rule. Okay? Alright, we're going to be using that here in just a second. If at any time you feel like I haven't answered the question you were looking for, and like if this is a late night sort of cram session where you're trying to get ready for an exam or a homework assignment, feel free to email me or leave a comment on down below the video. I'll try to respond as quickly as I can. I'm a tutor, so I can probably answer whatever questions you have. So if you're given two functions, f and g, now we're getting into the product rule part. If you're given two functions, f and g, terrible looking ampersand represent f, and you multiply them, you get a product. So I should have written lowercase g. Pardon me. You multiply them, you're going to get a product. So if you want to find the derivative of f times g, again we're using the prime notation, it's just shorthand. If you want to find the derivative of those, it makes sense that you would use a strategy called the product rule because you're taking the product of these two. All right? Doesn't matter what f and g are. Let's fix this so there's less glare on there. Maybe it won't matter. All right. It doesn't really matter what f and g are here. This is just a general formula like that general formula for the power rule that I showed you earlier. General formula is this, and it's easy to remember. Just get it in your head. F times g, take the derivative of that, is f prime times g plus f times g prime. Okay? F prime g plus f g prime. Sorry, lean in the camera and say it again. F prime g plus f g prime. That's the product rule. You can figure out a lot of derivatives using that product rule. It's probably the most common one. It's one I use the most in my upper level calculus classes. Okay, so that's what it looks like. All right. Remember, F and G are just letters. They don't mean anything by themselves. I could use A or H or W. It doesn't really matter, so don't feel like F and G really mean anything important by themselves. All right, so let's do a few examples. I got 2 examples for you. Say you're asked to find the derivative of the product of 2 functions, where f of x is equal to 2x cubed and g of x is equal to 1/2 x to the 4th. You see that? Okay, very good. 2x cubed, 1/2 x to the 4th. All right, and the box is in just because pretend this is separate from what we're doing. Pretend this is just what's written in your textbook or homework assignment or whatever. I'm going to give you 5 steps to solving these. I know you want to skip a lot of steps because you're in high school. I don't know, maybe you're college taking calculus for the first time. I took calculus in college for the first time. And you're in a hurry, you don't want to write steps you don't think you need to. If you want to get an A, just do these steps. Write them all out. Do it at least for the first homework assignment. If this is the first time you're doing this, just write these steps out. I can almost guarantee you'll get an A. All right. So the first step that you need to do, number 1, write the product rule, the general form that I showed you earlier. Do it for every problem. I don't care if you have 10 problems that you have to do tonight or 20 problems you have to do tonight. Write the product rule out for every single one. It will just help you remember it for when you eventually get to a test or a quiz where you're going to have to know it off the top of your head. So first step, write the product rule. F times G prime is equal to F prime G plus F G prime. Now notice I'm not doing the parentheses X. It's just mathematicians, scientists, they're all pretty lazy. And you don't have to write the X every time. It's just, that's more proper, but we're not going to worry about that here. So that's the first step. The second step is to write your functions. I already have my functions here, but I'm going to write them again because remember we're pretending that this is just from the textbook. So this is what everything outside of this box is what you're doing on your paper. So step 2, write your functions. F equals 2x cubed. G equals 1/2 x to the 4th. All right. The third step, write your derivatives. This is where that power rule that I showed you a minute ago comes in. All right. Derivatives of f prime. And employ that power rule. So remember, we bring down the first, the power that's up here at the top. It's a 3. We bring it down and we multiply it to this. I'm going to write the steps out clearly here and not going to skip anything for your sake. So we bring down this 3. We already have that 2 there. It's not going anywhere. It's going to get multiplied. You already know where this is going. So 3 came down. Write our x. Then we do subtract 1 from the exponent that was in the original function. So 3 minus 1, 2. What does that simplify to? 3 times 2, 6. So we have 6x squared. That's our derivative of f prime. G prime, I'm going to put a line, squiggly line down here just to separate these so they don't get confused. G prime, same thing. Bring the 4 down. 4 times 1/2 times x. Now you take your exponent and subtract 1 from it. 4 minus 1 is 3, x cubed. So if we simplify this, 4 times 1/2, it's 4 divided by 2, it's 2. So g prime is equal to 2x cubed. Very good. All right, now 4. Plug everything in. So if I have f times g prime and I want to take the derivative of that, I plug everything in back to step 1. F prime, that's the first one up. What is f prime? F prime was this, 6x squared. 6x squared times g. G was that. 1/2 x to the 4th. Plus, now, regular f, 2x cubed times g prime. 2x cubed. Again, that's f prime, that's g, that's f, that's g prime. Fourth step is just plugging in steps 2 and 3 into step 1. Okay? All right. Fifth step is just to simplify. All right. So if we simplify all this, f times g prime, we have 6 times 1/2. 6 times 1/2, it's the same thing as 6 divided by 2. It's 3. Now you can do x squared times x to the 4th. If you know your rules for multiplying exponents, when you multiply exponents, you add them together. So x to the 2 times x to the 4 is x to the 2 plus 4. 2 plus 4 is 6. So x squared times x to the 4th is x to the 6th plus. Now we multiply these together. 2x cubed, 2x cubed. Well, that's a nice coincidence. Didn't see that. Huh. All right. 2 times 2 is 4. Again, you see where the 4 came from. We have a 2 and a 2. Just multiply them. 4. X cubed times x cubed. Again, add the exponents. When you're multiplying exponents, you add them. So 3 plus 3 is going to equal 6. 4x to the 6th. Here we have a convenient situation that's not always going to happen, where you have like terms with your variable x. Both x's have a power of 6 that they're being raised to. So you can add those up directly. If this was like x to the 5th and x to the, 17th, doesn't matter. If the exponents are different, you can't add those together. But here they're the same, and we can. So we can simplify this even further, and we get 3x to the 6th plus 4x to the 6th. 3 plus 4 is only the only addition you have to do here. 7x to the 6th. So of these two functions, when you multiply them together using the product rule, the derivative of those two is equal to 7x to the 6th. Now I use some pretty easy functions here to demonstrate this first one. Maybe a few of you have already realized that you could have just multiplied those two at the beginning and used the power rule to solve them without going through all these steps. And I'll show you what I'm talking about and explain why we didn't do that. So if I took f, if I wanted to find f, I'll just separate all this stuff for a second. If I wanted to do f times g and find the derivative, instead of doing the product rule, I could have just done f times g and taken the derivative of that. What would I get? Say f times g. Let me get rid of this for a second. F times g is going to be equal to 2, these are the original functions, 2x cubed times 1/2 x to the 4th. Multiply your numbers first. 2 times 1/2. I think we know what that comes out to be. That's 2 divided by 2. It's 1, so it pretty much just goes away. I'll just put a 1 in there for whatever's sake. Now x to the 3rd times x to the 4th. X to the 3rd times x to the 4th, add the exponents together, you get x to the 7th. Dropping that 1 to simplify it, x to the 7th. So f times g is equal to x to the 7th. Now if I wanted to take the derivative of f times g, that's the derivative of x to the 7th. We can use our power rule to figure out what that is. Remember the power rule, you bring the exponent down in the very front and then you subtract 1 from the exponent that's still left there. So if we bring our exponent down, that's a 7. Put the x back, subtract 1 from 7, get 6. 7x to the 6th. That's the same thing we got with the product rule, as you should. If there's more than one way to solve a calculus problem, you should get the same answer no matter what way you solve it. So this is a great way to check yourself and see if you've done the right thing. If you're wondering why I went through all these steps, well, again, I'm here to show you how to do the product rule. So we started out with an easy one. If you get more complex problems, this is the way you want to do it. Specifically, this part right here. This is the main thing that I want you to take away and use to solve your problems. Write your original functions, then write the derivatives separately. It really helps, because when you try to do everything at once, which I know a lot of you are going to want to try to do, and it's probably what's causing you most of your headaches, when you try to just solve this all in one step, it's no good at the beginning anyway. The better you get at it, you can just solve it all in one step. But here at the beginning, seriously, this is a really good strategy to do. Try it for yourself. You'll see what I'm talking about. Okay, I've got one more problem to show you. Erase this real quick. And this is an example of a problem where you really need to use the product rule to do it. Okay, so again, we're going to pretend that this little box is just what's inside of our textbook. So we're going to say f is equal to x. I can't see that, I can't do very well. I'll write it bigger. F is equal to x. G is equal to, looks like a y, doesn't it? It's supposed to be a g. G is equal to ln x. Stands for the natural log of x. You probably already know. So let's first start out where I ended on the last one and multiply everything together first and then try to find the derivative. Remember how that was a lot easier when we did it on that first example? So let's do that first. What is f times g? F times g, x times ln x. It's pretty straightforward. X, L, and x. Okay, so what's the derivative of that? Can you use the product rule? No, I'm sorry, the power rule to answer that? This guy is going to cause you your trouble. Right here. Even if you already know the identity for how to take a derivative of the natural log, this is still kind of a hairy situation. Alright? You could use the power rule for this, but you can't use the power rule for that. You need what's called an identity, just something that you look up in a book, you know what the derivative of ln x is. It's a common thing. You'll get used to seeing it a lot in your calculus class, I promise. So we can't just start here. We have to use the product rule. All right, again, so we're going to do my 5 steps that I showed you a second ago. Do these 5 steps every single problem. I can't stress it enough. If you want to get good grades, seriously do it. Don't be lazy. All right, and honestly, if you take the time to do this now, you spend less time in the long run. Because if you try to take shortcuts at this stage when you're just beginning it, you're going to get it wrong, you're going to have to redo it, or you're going to lose points. Maybe you'll have to retake the class, you know? Take the time right now. Okay, first step was write the product rule. So, f g prime is equal to f prime g plus g f prime. There's little multiplication dots here in the middle. Okay? It will get redundant, it will get old. I can't stress enough, just do it. You'll memorize it that way. Step 2. Step 2 was to write your functions. Okay? F equals x. G equals ln x. Put my squiggly line in here again. Alright, step 3. was to write your derivatives. F prime, we'll use our product rule again. If you have an x by, or I'm sorry, our power rule again, if you have an x by itself, this is a pretty easy one to take a derivative of, by the way. I'll let you know the answer is 1. The derivative of x is 1. But if you want to explore y, x by itself has a 1 up there. It is raised to the power of 1. That is not a prime like you see here. That's prime, letting you know it's a derivative. This is just a 1, like x to the power of 1. So you would bring down that 1, multiply it by x, and you'd subtract 1 from that. 1 minus 1 is 0. So you'd have x to the 0. You can open your calculator up and put any number to the power of 0, like 5 to the power of 0, a million billion to the power of 0. Anything to the power of 0 is always 1. So this is just equal to 1. Cool. G prime. Here's your identity. The derivative of a natural log, and there's no steps that I'm going to show you how to solve this one. I'm just going to tell you what it is 1 over x. It's just what it is. Just memorize it. Derivative of the natural log is equal to 1 over x. You can look it up online or in a book, anywhere. It's just what it is. Okay. Step 4, plug everything in. So we plug these 2 and 3 into 1. And f, g prime is equal to f prime. F prime was what? It was 1. Let's just write a 1 for thoroughness times g. G was ln x. ln x plus g, again, oops. Guys didn't stop me. You should have raised your hand and let me know that I wrote something wrong. I didn't do it the first time, I remember that. F g prime. Regular f, which is x. Get rid of that. Confused. Remember, that wasn't a prime, that was just a number 1. X times g prime, which is 1 over x. Okay? Step 5, simplify it. F, g, prime, what's 1 times ln x? It's just ln x. Equal to ln x plus x times 1 over x. What is that? They just cancel each other out. This is like 2 over 2, or 3 over 3. 2 over 2 is equal to 3 over 3. They all just equal 1. So x over x is 1. So the answer, your derivative, to these two functions is ln x plus 1. Now remember, when we multiplied them, f times g, we got x ln x. Is it clear or obvious that the derivative of that is equal to ln x plus 1? Maybe it is. It isn't to me. You have to do the work to figure it out. And you definitely can't just use, you can't multiply them ahead of time and think you're going to make it easier on yourself. For a problem like this, you definitely have to use the product rule. So this is absolutely one where the product rule is necessary. Okay? All right, that's it for the product rule. I hope that was helpful. Again, the main thing I want you to take away from this and employ is that part, writing out your functions and your derivatives separately. Okay? Let me write down the steps that I used one more time, just so if there's anybody that's that ambitious and wants to know what my steps are, again, just written out. Step 1 is write product rule. That is f g prime is equal to f prime g plus f g prime. Step 2, write functions. functions. F equals something, whatever, G equals something else. 3, right, derivatives. F prime equals something, G prime equals something. 4, plug everything in, plug in. You take your functions and your derivatives and you plug them back into your product rule. Sorry about that. And then 5, the very end, see that? Barely. 5 is just simplify. I'm a tutor, so I know a lot of y'all have teachers that tell you not to simplify it for good reason, because a lot of times you can have the right answer here at step 4 where you plugged everything in, because if you plug it all in and you plug it in correctly and you have the right things, you have the right answer. And sometimes when you end up going to simplify it, you can make some kind of algebraic mistake and mess it up there and get the wrong answer. So if your teacher tells you not to simplify it, obviously don't simplify it. That's it. Again, to restate, if you have any questions that I haven't answered, or if you have questions about the quotient rule, or more questions about the product rule, the power rule, the chain rule, any of that stuff, send me an email. I'm a tutor. I'd love to be able to help you. Helps me spread my name. So we can work together on this one. Thank you for watching this. If you stuck around to the end, it's looks coming up on almost 30 minutes here. I'd hope to make this a 5-minute video, so it didn't quite work out that well. But anyway, thank you again. My name is Tyler, and have good luck in calculus.